On number 6, the first thing that we're going to do is these are similar triangles. That's why it uses the little squiggle, not the equal sign. It's not congruent. You can tell with your eyes that they are not the same size. To set up a proportion, your proportion is going to be the hardest part to set up. So we're going to do big triangle divided by small triangle. And we know that the proportion is going to have like 2 fractions with an equal sign between them because that's how we're cross multiplying. So if I'm looking at the big triangle, it doesn't matter which one I use. I just have to pick something that's on the big triangle. So do you want to use 39 or 42 first? It literally doesn't matter. Anybody care? 39, sure. So let's use 39. So the tricky part is figuring out which side is similar to 39. 39 is on BC. From B to C, that's the first 2 letters of the similarity statement. We're on number 6. Oh no, what's happening? Oh no, what's happening? My thing restarted. Pause. Okay, there you go. Okay, sorry about that. Okay, so anyways, so we have 39 from the big triangle. The first 2 letters are BC, so it has to match with the first 2 letters of the second triangle. So the second triangle says F to G. Some of you can tell just by looking at the triangles that those sides are similar to each other. That's fine if you can tell that. If you can't tell that, use the letters. They go in order for a reason. The first 2 letters match the first 2 letters. So they have to be in the same spots on those statements. So 39 technically matches with 4x plus 2. And then on the big triangle, what have I not used yet? $42. So 42 is right here. So let's use process of elimination. Let's use our brains. What's 42 going to match with on the small triangle? Perfect. 5x minus 2. And then just like yesterday, we are going to cross multiply. So we'll actually go through this whole problem together, and then we'll set up 2 other proportions. So I'm going to cross multiply. I'm going to start by going left to right. Remember, this is like the butterfly. So I'm doing 39 multiplied by 5x minus 2. Equal sign stays in the middle. And then I'm going to cross multiply, making a butterfly the other way. So going this way. So I'm going to do 42 times 4x plus 2. So I'm going to have to use the distributive property. So I'm going to distribute the 39 into the parentheses. So 39 times 5x, I need a calculator because I don't know this off the top of my head. 39 times 5 is 195x. 39 times 2 is 78, so minus 78 equals, and then on the other side, I'm going to do the same thing. I'm going to distribute 42 into the parentheses, so 42 times 4 is 168x, and 42 times 2 is 84. So now you have 2 things that you could do at this point. You could either add the 78 to both sides, or you could minus 84 to both sides. So would you prefer to add or would you prefer to subtract? Add. Let's add 78 because you're using opposite operation. So I'm going to add 78. So I have 195x equals 168x. 84 plus 78 is, thank you, 162. And then at this point, I'm going to subtract the x's to both sides. So I'm going to minus 168 to both sides. And you will get larger numbers for these problems. I don't know really why, but so a lot of people are like freaking out because they're like big, but they end up being nice. So 162 or so 168. None of the answers are like massive. So you get 27x equals 162. And then I'm going to take 162 and divide by 27. So I get x equals 6 for my answer. You don't have to plug it back in today. Okay. So let's set up another proportion because the proportion's the hard part. A lot of you were getting really good at solving equations. This whole pink part we're really good at now. It's like these top two sections that are the hard parts because that's the new stuff. So let's go to number 8. So number 8 technically has two triangles in the picture. Some of you can see both triangles. Some of you are like, what are you talking about? Some of you are talking about trapezoids. Okay. So there is a trapezoid in this picture, but disregard the trapezoid. So there's two triangles. We have the large one on the outside. So this is my big one. Boop, 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 on the outside. And then there's also a small trapezoid technically in the center. So these are the two triangles that we are comparing. They are similar to each other. Okay. So what we're going to do is we're going to set up the same type of proportion. We're going to do big triangle divided by small triangle. We know I have two fractions and I know the equal sign is going to go smack dab in the middle. So now I'm looking at the big triangle and I'm picking one of the numbers on the big triangle specifically. It doesn't matter which one I start with as long as it's on the big triangle. So does anybody see something that's on the big triangle that I should use? 40, okay. So 40 is the whole length of the large triangle. This whole thing is 40 going all the way down. So that 40 goes with the big triangle. Now I have to figure out what's that same length, but for the small triangle. So if I'm looking at the side, I know that this whole thing is 40. I know that this little piece is 5. So what is going to be the length of the small triangle? 35. Because the whole distance is 40, this has to be 35 because 35 plus 5 makes 40. So I'm going to use 35 underneath. What's the other portion of the big triangle? Because big has to go up top. So what's the other dimension that they give me on the big triangle? 3x minus 7. And then what's going to be that matching piece on the smaller triangle? 2x plus 2. So this is the big one. This is the small one. So 2x plus 2 is going to go in the denominator. So that's how you would set up that one. Should we set up one more together before you start practicing these? Let's go on the front because I think these ones are confusing just because they're overlapping themselves. So let's do the other one that looks like that. Let's go to number 4. Okay, so number 4, there's two triangles in this picture. You have the smaller inside one, technically, and then you have the large outside one that includes the small one. So this whole thing represents the big one. So I'm going to set up the same type of fraction. I'm going to do big divided by small equals big divided by small. So I'm just going to put a b over s. So I have my little fraction, I have my equal sign, got a little fraction. So on the big triangle, it doesn't matter what I'm starting with as long as it's a dimension on the big triangle. So I'm either talking about this or I'm talking about this. So what portion do you want to use? You can't use 20. 20 would be just for the small. The whole distance would be 28. So from here all the way over would be a total of 28 because I would have to add them together. So if I put 28 at the top, try to see if you can fill out the rest of this proportion. Try to see if you can figure out what goes underneath, what's going to go up top, and what's going to go underneath. So take a second. Try to fill in the other 3 spots because the proportion setting up is the hardest part. So if 28 is the whole length of the large triangle, what is going to be the distance of this side on the small triangle? $20. So from here to here is 20. So that's going to be the same side, just on the small triangle is going to be 20. Now on the big triangle, what's left that has to go up top that I haven't used yet? Two x plus 3. Perfect. So this is this side on the big triangle. What's the corresponding side on the smaller triangle? What side matches that? What am I going to have to use? 15. So 15's right here. And then you would cross multiply and solve for x. So start with the ones that I set up for you, and then you can work through the other ones for classwork today, because today is just a practice day. If you want to